Exercise 1I, perimeter area and volume from the rates and ratios unit. So the learning intention for this lesson is to calculate distance using a scale, the area of land and the volume of water using the trapezoidal rule where necessary. Okay, so as in the last exercise, you may have some trouble using the online textbook for this one because it all depends on how you've zoomed in on the image with the measuring and things like that. So you might have to leave some questions to use the hard copy textbook from in class. Okay, so when I'm doing the examples today, I'm using the measurements from when I measure the hard copy textbook, okay, so that it works. I'm not measuring it off my screen because it all depends on how I've zoomed and things like that. Alright, so starting with perimeter. So perimeter is the total length of the outside of a shape. Okay, so if you were to like put a fence around a shape, that would be finding the perimeter. The perimeter of a piece of land can be found by looking at aerial photographs of the land rather than actually measuring the land. Okay, so that's a lot more practical than physically going out and measuring large bodies of land. Okay, now how you would do that would be you would obviously take an aerial photograph and you would find an object, I guess, from the aerial photo that you knew the measurement of, measured that, and use that to calculate the scale of your picture to the actual measurement. So in this case of the swimming pool, you might know, for example, the length of that boat, and then use that to determine the scale. Alright. Otherwise, it is a swimming pool, so you might just do your research and know, okay, well, it's a 50-meter swimming pool. I'm going to use that for calculating the scale. So it says this aerial view, on Google Earth shows a 50-meter Olympic swimming pool outlined with the path tool. That's just that red box tool. What is the scale used on the image? Okay, so if I were to measure this, like using the textbook, it measures out to be 3.1 centimeters. Okay, and we know that it's 50 meters in real life. So 3.1 centimeters equals 50 meters. Now I like my scale to always be in the same unit, so I'm going to rewrite that as 5,000 centimeters. Okay, and then I want to find the scale, so I need the first number to be 1. Now I'm writing in red. So divide that by 3.1, divide this by 3.1, and you get 1 centimeter to 1613 centimeters. So your scale is 1 to 1613, because you don't need to write what the units are, whether it's millimeters or centimeters, it'll all work out the same. Okay, so that's our scale. Question B says use the scale to determine the length of the boat in meters. Okay, so if I measure this boat on the page, it's exactly 2 centimeters. Okay, or 20 millimeters. Alright, so to calculate, I've got 1 centimeter. I don't know why I did millimeters. 1 centimeter is my scale to 1613 centimeters. On the paper, it's 2 centimeters. Okay, so to get from there to there, I multiplied by 2. So I need to multiply this by 2. So I get 3,226 centimeters. Now they want it in meters, so I'm going to have to divide by 100, and I'll get 32.26 meters. Now when they say they want the boat in meters, they want you to round to the nearest meter, so 32 meters. However, to be safe in an exam, particularly if I was unsure and they didn't specify like if they wanted you to round or anything like that, I would always give that one. And you could give that as well. But you should always give this anyway, just in case there's a rounding error. Okay, so you won't lose any marks. Okay, so that's that first one on perimeter. Now looking at area. Area is a measure of the amount of space contained inside a shape. So if a piece of land has an atypical shape, the area can be estimated by dividing the diagram into a square grid and counting the number of squares. So you would have done that back in primary school when you first started working with area. And you kind of estimate area. We do that in real life as well. We've got an unusual kind of block of land. Okay, because land's not always cut up in squares and rectangles. Sometimes you have odd shapes. Alright. So it says a warehouse is shown on Google Earth. The red scale bar represents 42 meters at the ground. Okay. So again, that red scale bar, if I measure it with my ruler from the textbook, it's actually 1.2 centimeters. Okay. So that way you know that anything that length, That's your scale. 1.2 centimeters is 42 meters in real life. So calculate the dimensions of the land occupied by the warehouse building using the scale. So to find, first I want to find my scale. So I know that 1.2 centimeters equals 42 meters. Okay, so I'm going to divide both sides by 1.2. Divide by 1.2. And I get 1 centimeter equals 35 meters. That's my scale. Okay, so that's going to help me with all my calculations. Now this is tricky because of the measuring of the book. So let's calculate, what do they want? Calculate the dimensions of the land occupied by the warehouse building. So they want to know what all of these measurements are. So what I'm actually going to do is I'm going to write in what they are when I measure them with a ruler. And then we'll be able to calculate. Okay, so AB measured 4.2 centimeters. Next one was BC, so down here. That one I had at 1.2. Then CD, which is this here, that's 1.3. ED is 1 centimeter. EF was 3.2. AF is this one here, which was 2.5. And then EC, which was that diagonal there, was 1.6. Okay, and they want the dimensions of that building. So we need to convert all of them using the scale. Okay, so I'm just going to rewrite them all. So AB, BC, CD, ED, EF, AF, EC, and their measurements were their drawing measurement is 4.2. These are all centimeters. 1.2, 1.3, 1, 3.2. Luckily I measured these quickly before. Okay, and now we want to convert them to their actual, so we're going to multiply each of them by our scale, which is 35. So times them all by 35. Just use another colour so we don't get confused. Okay, and you'll get 147 meters, 42 meters, 45.5 meters, 35 meters, 112 meters, 87.5 meters, and that's 56 meters. So that's actual. Okay, so that's all your dimensions. Now it says calculate the area of land occupied by the warehouse building and answer correct to the nearest meter. So it's a little bit of an odd shape. Okay, it's pretty much like a little trapezium. Okay, so what I think the best way would be to find this entire rectangle and then just take away that triangle. Okay, it's actually not a trapezium because it's 5-sided. It's some sort of pentagon, an irregular pentagon. Okay, so let's find the whole rectangle. So the area will be length times width. The length, and we're using the actual measurement. So 147, which is the entire length, times 87.5, and that'll give you 12,863 meters squared. Then your triangle is base times height divided by 2. So using the actual measurements, it's 45.5 times 35. Divide that by 2, and we get 796.3 meters squared. So the total area, we obviously need to take away that little corner triangle. So it'll be 12863 minus 796.3, which equals 12,066 meters squared. Okay, so that's the total area of that building. Alright, and last one, volume. Okay, so this is a really quite an important exercise. I know you have looked at the trapezoidal rule in year 11, so you should be pretty familiar with it. It seems to come up in every exam, whether it's a trial or a HSC or even an in-school exam, we try to include them a lot because you need to be very familiar with them. There's so many good questions asked with using the trapezoidal rule, and they're always worth a decent amount of marks, so 4 to 5 marks, and they're pretty easy to do. Okay, so you don't want to throw those marks away. Alright, so volume. If water covers an area, such as the bottom of a pool, tank, or reservoir, to a constant depth, its volume can be calculated using volume equals A times H. So A of area of the cross section times by height of the shape. Now, V is your volume, and alright, so let's have a look. So, having a look at this shape here, if you were to find the area of the cross section, you're going to go, I don't really write my formula like that. I'd say DF plus DL, so D first and D last, and these are parallel. Multiply them by the width, so the length joining them together, and divide the whole thing by 2. Okay, now to then find the volume, you would multiply it by the height of the shape. Okay, this only works if the depth of the body of water is constant, meaning it's not shallow on one end and deep on the other. Alright, let's have a look at this one. It says the shape of the water in a pool of constant depth with an irregularly shaped bottom and top surface is shown. Dimensions are in meters. Apply the trapezoidal rule for area to approximate the volume of water in this pool. Okay, so let's work out the trapezoidal rule for the top first. So it's DF plus DL multiplied by the width divided by 2, and then you're going to multiply that by the height of the shape. Okay, so in this case, the width is 8, bracket 6 plus whatever that is, that's 4. Divide that by 2, multiply all of that by, what am I writing H? By 1.5. Okay, and what you'll get is 60 meters cubed. Okay, now B, 100 millimeters of rain falls on the pool. Assume it has vertical walls that extend vertically above the water surface so that no water runs out or into the pool, and the depth in all parts of the pool does not vary. By how much does the volume of water in the pool increase? Okay, so we're adding 100 millimeters. Now, 100 millimeters, everything we've calculated already has been in meters. So the first thing you want to do is go from 100 millimeters and convert that to meters. So to get to centimeters, we're going to divide by 100. Okay, so it's so what am I saying, divide by 100? Millimeters to centimeters, divide by 10. So you'll get 10 centimeters. That's 100 millimeters. And then divide that by 100 to get to meters. So you get 0.1 meters. Okay, so that's how much rainfall we have. Now, we know that the area of the cross section is going to be this without the 1.5. So the area of the cross section itself is 8 bracket 6 plus 4. Okay, for that top bit, which is 40. Okay, so to work out the rain, if we go 40 times 0.1, we'll get 4 meters squared. So 100 millimeters of rain adds 4 meters squared of volume to our pool of water. Okay, so how much does it water in the pool increase? It's 4 meters squared. Okay, all right. Make sure you have a look at the additional questions for this one. Hopefully there's some challenging ones there with the trapezoidal rule as well.